Alrighty, so we are going to start on 1.3, which is the elimination method. Okay, and so we're still going to work in two variables and two equations. And two learning targets where we're going to learn that elimination method, or rather refresh it as its review. And then we're also going to work on solving real life problems using this method. Okay, so what we're going to do is work on the elimination method. Okay, now the elimination method is all about creating opposites in variables so that they essentially cancel out, because if I have the number 5, what's the opposite of 5? Well, hopefully you all can tell me that that is the number -5, and that when I add those two numbers, I actually add to 0. So when I create opposites, so for example, I'm going to try to create opposites in certain variables here. And then when I add them, they cancel out to 0, and then it's an equation with one variable. And those are easier to solve. Okay, so we're going to work on doing that today. Okay, and so let's just go ahead and get started. So basically what I want to look at is I want to look at each of my x variables and y variables. So as I look at my x variables here, you just want to ask, like, can 2 turn into whatever the opposite of 4 is? So like, can this 2x here become the opposite of what 4 is? Easily, just using like basic multiplication of like multiplying by a number. Well 4, what's the opposite of 4? Well, that's -4. So can I multiply 2 by some nice neat number and get -4? Well, yes, I can. Okay, so this is more than likely where we're going to create our opposites, but what we want to do is we do want to look into the y's as well. So the y's, they're both negative, okay? So, and then basically you just want to look at the 3 to the 5. Like, what's the opposite of -5? Well, it's +5. Is there like some nice neat number I can multiply 3 by, or -3 by, to become +5? Although there is a number out there that will do that, it's not necessarily a nice neat one. So that kind of cements that, hey, we can easily create opposites in the x's. And since we can easily create opposites in the x's, that's what we're going to do. Okay, so I want to create opposites in the x's. So can 2 multiply up to -4? Easily. Answer is yes. What do I have to multiply that 2 by? Well, I would have to multiply by -2. So what I'm going to do is I'm going to take that entire top equation and I'm just going to scale it up and multiplying it by -2, because everything stays in balance if I multiply one side and the other side by the same value, -2. So we basically just have to distribute this across. -2 times 2x is -4x. -2 times -3 is a +6y. And -2 times 6, -2 times 6 is -12. Okay, so basically all I did was scale that up, and now you can see in the x's I have opposites. I have 4x and I have -4x. So why is this important to create opposites? Well, really what we're trying to do is we're trying to eliminate a variable completely, and really what we just want to do is we just want to add the two equations together. And we can do this because we know we're looking for the spot where we have the same x and y ordered pair. So I am just going to go ahead and off to the side, let's go ahead and add these equations together. Well, 4x and -4x, well, 4 plus -4 would be 0. So this cancels out just to 0. So I'm not going to write anything here. But what about -5y plus 6y? Well, I'm adding a negative and a positive, okay? And I know each one negative here is going to cancel out with one positive here. So how many more positives are in this 6 than negative in this 5? -5. There's 1, so there's 1 positive y. Okay, and then we're going to do the same. We're going to go 8 plus -12. 8 plus -12. Well, again, each positive here is going to cancel out with one negative here. So how many more negatives are in this 12 than positives in this 8? And hopefully you can tell me there's 4 more negatives. So I get or 1y is equal to -4. And that just means that my y value is equal to -4. Okay, so this is basically what you're trying to do. You're trying to create opposites by multiplying parts up. And then when you're going to add them, because the variables are going to cancel out. And you're going to be left with one variable and some numbers. And then you just have to do a little bit of solving. Okay. As always, you don't want to just find one variable. You need to find the other. So you need to take this value here and you got to replace it in one of the other two equations. It really doesn't matter. Although I would suggest picking one of the original ones and not this red one I have here. You could, but I just would suggest using one of the original ones. Okay, so I'm just going to pick the top one because why not? So 2x minus 3 times y, which is negative 4, is equal to 6. Okay, so then we have negative 3 times negative 4, so now I get 2x plus 12 is equal to 6. And then I just have to solve by subtracting 12. Okay, 6 minus 12 is negative 6, and then divide by 2. All right, x is negative 3. So I'm pretty confident that my answer is negative 3, negative 4. All right, we can always check using the calculator. Alrighty, so I just have to do the left-hand sides with the x and the y. So 2 times, and remember the negative number button is different from subtraction, that this is subtraction and this is negative number. In this situation, I'm trying to plug in negative 3, so I'm going to use that negative number. Then I'm going to minus 3, and notice that these are different than negative 3 and minus 3. I'm subtracting here, so I'm going to put minus 3, and then I'm going to go times negative 4. And when I hit enter, I should get 6, which I do. And so then I'm going to check the next one. Oh, I meant to put minus 5 here. And I get 8. Okay, and so that's just verifying that that is indeed my answer. Okay, so what I would like you all to do is pause the video, move on to A, and check it. Okay, so I'm assuming that you have already done this problem and that you're just trying to see if your work worked out. Okay, so the first step is you just want to figure out where you want to create your opposites. It looks like I could multiply this top equation by negative 2, and then I would have opposites in the x's. Another great option would be I could multiply this bottom equation by 4, and then I could add here, I would have opposites in the y's. Now, either will work. You should get the same answer as long as you're doing all of your number crunching and solving correctly. But I think I'm just going to multiply the bottom one by 4. I think when I have the option to multiply by a positive number instead of a negative number, I'm more inclined to do that, just less likely to make a silly mistake. Although the other one would work as well. So I'm going to get 8x plus 4y is equal to 4. Okay, that's me distributing 4 to everything in this problem. And then I'm just going to copy that top equation right below it, just so they're stacked up for me to kind of see and work. Okay, so now that I see I have opposites in the y's, I'm going to go ahead and add my two equations together. Okay, so these add to 0, so they indeed just kind of cancel out. Okay, but they cancel out because they add to 0. Okay, 8x and 1x is 9x, and 4 and 5 is 9. Okay, then I just have to simply divide by 9 to get 1. Okay, next step would just be plug it in to either equation. So I'm just going to say that this is 2 times 1 plus y is equal to 1. 2 times 1 is 2. And then I need to subtract 2 from each side just to find out that y is equal to negative 1. Okay, doesn't take a lot of time to check your work, so let's just go ahead and do that. I'm going to hit 1 minus 4 times negative 1 for the first one, and that is going to be 5, so that is my answer. And then the next one is going to be 2 times 1 plus, and then y will be negative 1 here. And then that's 1, so this checks out. That's my answer. Alrighty, so this is kind of just like your bare bones basic example of how to use elimination. And for us, how I'm just going to refer to it as elimination is just strictly going to be looking at ways to create opposites. Now, if we look at the top ones, like these problems worked out really, really nice for us because we just had numbers that multiplied up to each other really, really easily. Like if you look at the first example, the 2 multiplied up to negative 4, super easy. Here, the 1 multiplied up to 4 really easily, or this 2 or this 1 would have multiplied up to -2 easily. Well, that's not always going to be the case, and often is going to require just a little bit more work. And so sometimes you're just going to have to multiply both equations. Okay, now there isn't necessarily a wrong variable to pick again. Often there's easier ones, but you just have to figure out what's going to work for you. So as I'm looking at this here, I'm just trying to figure out whether, okay, so I'm looking at the smaller number and the smaller valued number, and I ask myself whether 5 is going to multiply up to +7 or -7 really easily. And the answer to that is no. So when I look at these two here, 8y has a smaller value. Okay, so I have to figure out whether this 8y is going to multiply up to 12, like easily with a nice neat number. And the answer to that is just no. So this is going to be one where I'm going to have to multiply the top equation by a value, and then I'm also going to have to multiply the bottom equation by a value. Often I would just pick the one that is going to have smaller numbers, but again, you can do this however you'd like. So the top equation, okay, so I'm looking at this, one's positive and one's negative, and that's a good thing because then that means I can just multiply both equations by a positive value. Where that might be different if I have both negatives or both positives, then one number is going to have to be negative, and you actually can see that would happen here. Okay, so what I'm going to do, and really, I just know 7 and -5 both multiply up to 35. I know this because I literally just would go 7 times 5. So really, I'm just going to, on the top equation, I just want to get that to +35x. And the bottom equation, I just want to get that to -35x. So what do I have to multiply 7x by to become 35x? Well, I just have to multiply that by a +5. Okay? And so then I have to look at the bottom one, and I look at -5x, and I have to ask myself, what do I have to multiply that by to become -35x? And that one's going to be 7. Okay? It's not a coincidence that like 5, I know it's -5, but I have 5 here, and there's 5 here, and a 7 here, and a 7 there. Often I found just for students that's going to be like the easiest way to go. All right, so, and again, these are both positive numbers because I already have one that's positive and one that's negative. Okay, so let's go ahead and distribute. So 5 times 7x is 35x. 5 times -12, I believe is -60, but I want to double check. It is. And then -22 times 5. And that's -110. Okay, so as you can see, the numbers are going to be a little bit bigger, but ultimately the process is going to be the same. So 7 times -5 is going to be -35x. Which is good because, as I can see, I already have my opposites here created, and then I'm going 7 times 8 to get 56y. And then 7 times 14, which is 98. Okay, so now I'm looking at my problem, and I've just scaled, in this one, it's just the same concept. You just have to scale both equations up. Okay, so now I look here, and I do have opposites in the x's, so that means I'm just going to add the equations together. 35x plus -35x, they cancel out to 0. And then -60y plus 56y. Okay, well, there are, each positive is going to cancel out with one negative here. So there's 4 more negatives in this 60y than there are positives in this 56y. So I know that this is going to result in -4y. Okay, and then here, kind of the same thing. There are 12 more negatives in this -110 than there are positives in this 98. So this is going to be -12. And then I just have to solve by dividing by -4 and getting, this is actually +3. I accidentally almost put negative, but it is positive. Okay, from here, same thing. Plug it in, find your other solution. So I guess I'll just pick the bottom one. The numbers are a little bit smaller doesn't particularly matter. You could use the top one if you wanted to. So this is going to be negative 5x plus 8 times 3. All right, and that's going to be equal to 14. So then I'm going to have negative 5x plus 24 is equal to 14. Subtract 24. To get negative 5x is going to be equal to negative 10. Okay, 10 more negatives in this negative 24 than positives in this one. Alrighty. And then divide by negative 5 to get x is 2. Okay, and we would just like to check our work real fast. And we're just going to have the calculator do that. Okay, so minus 12 times 3. When I hit enter, I'm hoping to get negative 22, and I do. Next one would be negative 5 times 2 plus 8 times 3, and that's 14. So that is indeed our answer. Okay, so hopefully you all have already picked up on kind of what I'm asking you to do, and the next thing I would have you do is try letter B on your own. Okay, so at this point, I'm assumed you've already tried this. You're looking for your work to be checked. Okay, this one, the only real curveball thrown at you, the numbers are smaller, so hopefully they're more manageable, is that I have 2 positives and 2 negatives. Okay, so when you have the same sign, you're going to want one number that you're multiplying to be positive and one number to be negative. That's what's going to create opposites for us. Otherwise, we're just going to end up with the same number. Okay, now it doesn't matter which one's positive, which one's negative, and it doesn't matter what variable you do. You just want to create one positive number and one negative number so that they're opposites. Okay, so I guess I'm going to pick the y's because the y's have a little bit smaller values in 2 and 3. So I'm going to decide to multiply the top one by 3. Okay, and that's going to give me the negative 6 here in the y, thinking ahead. Okay, so if I multiply the top one by 3, what do I need to multiply the bottom one by? So I have opposites there. Hopefully you're not saying 2, because 2 would get me negative 6 also, but instead, negative 2. Okay, this one's going to be, this is how I'm going to create opposites. In fact, if you did multiply by 2 and you got negative 6x and negative 6x, you could go ahead and actually just subtract the 2 equations instead of adding them. But just in my experience, I've had students have a little bit more errors in when they subtract as opposed to when they just add all the time. Okay, so let's go ahead and distribute the 3 across the top. So 3 times 3x is 9x. 3 times negative 2y is negative 6y. And 3 times 2 is 6. Okay, and then I'm going to go ahead and distribute the bottom one. Negative 2 times 4x is negative 8x. Negative 2 times negative 3y is a positive 6y. And as you can already see, we have opposites. And then negative 2 times 1 is negative 2. Okay, I do indeed have opposites, so that means I'm good to add these 2 equations. 9x plus negative 8x is going to be a positive 1x. These are going to cancel out completely. And then here I'm going to have 4. Because there's 4 more positives in this 6 than negatives in that 2. If you wanted to, you could divide by 1. Otherwise, this is the same as just saying x is equal to 4. Lastly, we just need to plug it in, so I'm going to go ahead and do that. 3 times 4 minus 2y is equal to 2. Well, this is 12. And then I need to subtract 12 from each side. And that's negative 10. And then divide by negative 2. So this is y is equal to positive 5. Alrighty, we can just go ahead and check our work with the calculator because it really doesn't take all that much more time. And then, so the first one is going to be 3 times 4 minus 2 times 5. And I should get 2, which I do. And then the next one is going to be 4 times 4 minus 3 times 5, not 8, 5. And that gives me 1. So that just verifies that this is my answer, and it doesn't even take that much work. which is going to be super helpful when you come to the test, right? Okay, before we do the word problem, one thing I want to talk about that I actually forgot to talk about in the last section, but I needed to. But if you refer back to your notes 1, page 3 at the bottom, we talked about, the graphing version of this. When I get one solution, it's just crossing through. Okay, this is going to happen when you just get x is equal to some number and y is equal to some number, right? Because then you're getting an x-y pair. Okay, so when you're solving algebraically and you just get x is equal to some number, y is equal to some number, that just means you have one solution. Okay, when are you going to get an infinite amount of solutions? Well, if you're doing your work, you're working through, your variables cancel out completely. So all of your x's are gone, and you get a statement, let's say it's like this, 4 is equal to 4. Okay, I will often refer to this as a true statement. Okay, so it doesn't have to be 4. It could be 8, 7, 2.83. It could be any number. But if all your variables cancel out and you get a true statement, that means there's infinite solutions. That means the lines that you're talking about are overlapping perfectly. Okay, the last one would be if you're working through, all your variables cancel out, and you get something like -6 is equal to 17. Okay, and this is what I will just refer to as a false statement. Okay, and what does this mean? This means that you're dealing with two lines that are going to have the same slope, but they have different starting points, so they're never going to cross. Okay, so this is going to be no solutions. So if you ever get work, your variables cancel out, you get false statement, it's no solutions. Your variables cancel out, you get true statement, it's infinitely solutions. But if your variables don't cancel out and you're just getting x is equal to a number, y is equal to a number, your answer is just that ordered pair. Forgot to mention that before, but we did need to refer back to it. Okay, so basically all that's left is we're just going to keep working through the problems, the word problems. This particular one, we'll work on. And we want to focus on writing the equations because that often is the hardest part. So we don't want to spend too much time thinking about solving. So when I solve this, I'll probably go kind of right on through it just to save you and myself some time. But otherwise, I'm going to try to spend most of my time thinking about the problem and how we can represent that algebraically. So a customer hires a caterer to prepare food for a party of 30 people. Okay, so just already in the top of my head, I'm thinking like, okay, it's for 30 people. So I know if I take all my people together, it's 30. Okay, a customer has $80 to spend on food and would like there to be a choice of sandwiches and pasta. Okay, a $40 pan of pasta contains 10 servings and a $10 sandwich tray contains 5 servings. How much the caterer must prepare enough food so that each person receives at least 1 serving of food. How many pans of pasta and sandwich trays are there? Okay, so again, we want to define our variable, and our variable is often going to come from the question being asked. Question being asked is how many pans of pasta. Well, so let's just say x is going to be my pans of pasta. And then my other variable would be sandwich trays. And again, this doesn't have to be x and y. They could be flipped around. You could use other letters, to be completely honest. Okay, so let's just think about the money. I think often money will be the easiest one. We know like all together we're spending $80. And that's going to be composed of the money spent on pasta. So how can I represent money spent on pasta? For each pan of pasta, I'm going to multiply it by $40. Because if I have 1 pan of pasta, it's $40. But if I have 2, it's $80. So you just take your price and you multiply it by what you have. So this is going to be 40x plus, well, that $80 isn't just the pans. It also contains the sandwich trays, okay? And those are $10 a piece. Okay, that's really our first one. Often money, I think, tends to be one that's pretty easy. So let's think about the other one. The other one is going to be talking about people, and people will also represent like servings. So altogether we have 30 people. That means I need at least 30 servings here. Okay, so if I'm doing servings, how many servings is 1 pan of pasta going to give? Well, it gives me 10. It says so right here. Okay, so the $40 pan of pasta contains 10 servings. So that means for every single pan of pasta, 10 servings will be applied to it. So one pasta pan will serve 10 people, 2 pasta pans will serve 20, 3 would be 30, so on. And then a sandwich tray does 5, so this would be 5-way. Okay, so when we get to tests, I don't have a personal preference on how you solve word problems. All I care is that you're able to, okay? So any method you want, if you want to do it all in the calculator, that's fine. But some things I need to see is that, like right here, I would need to see this. My expectation would be I need to see variables defined and I need to see equations written. As far as solving goes, I really don't care how you do that. Just do whatever. Since we're in the elimination method section, I am going to use elimination, but feel free to solve the word problems in your favorite method. Okay, I want to create opposites. I think in the y's is going to be pretty easy because I just have to multiply this by -2. So I'm going to multiply this by -2 to get -60 is equal to -20x minus 10y. And then I'm just going to drag this top one down since I haven't done anything to it. Okay, so now I just need to go ahead and I can add these two equations together because I have opposites in my y's. That means they're going to cancel out to 0. -60 plus 80 is a positive 20. There's 20 more positives in that 80 than there are negatives in that -60. And same here, this is going to be 20x. And these cancel out. So then I just need to divide by 20 to get 1 is equal to x. Okay, knowing that 1 is equal to x, I can just go ahead and plug it into, I suppose, the bottom one. Again, the numbers are a little smaller. So 30 is equal to 10 times 1 plus 10y. Oh, 5y. Okay, so this is 30 is equal to 10 plus 5y. Minus 10 minus 10 is equal to 5y. And then this is 4. Okay, and looks like I ran out of room, but looks like what I did do here is I just multiplied this to get 10. Then I subtracted 10 from each side. 30 minus 10 is 20. 20 divided by 5 is 4. Okay, so I believe my answer is the order pair 1, 4. Okay, if you wanted to go ahead and check that, you could. I'm going to tell you that is correct for this particular one. Okay, but another requirement I need to see when you're doing these word problems, and this will be consistent when you're doing tests, is just one quick sentence explaining to me what does 1, 4 mean, because that doesn't mean a whole lot. If somebody asks you, what does that, or this question, and you say 1, 4. Okay, well, 1 of what and 4 of what, if they even know what that means. Okay, so what does this mean? Well, we said x is pans of pasta, so we will need 1 pan of pasta and 4 sandwich trays. Just real quick, easy sentence explaining what your answer means, and that is going to be considered good enough. All right, so we are done with the 1.3, which is kind of the end of actually our review of this section. And hopefully what you're really focusing on is, how well can you simplify an equation, get a variable isolated, solve for a variable, all these different skills, because really after this point, it's kind of going to be considered that a lot of these are basic skills. So that's why I use these first 3 review sections, is to kind of get you caught up on some like basic algebraic properties that you're going to really see throughout. Otherwise, you can move on to the 1.3 homework, and I will see you next time for the 1.4 homework or notes.